Elevate TV, advancing kingdom lifestyle.
Ladies and gentlemen, welcome to another episode of the Gigi Report. It's exciting to be back on the show. I believe that you love this show and you've learned a lot, and today we have something amazing for you. All right, so welcome. Today we're going to focus on the idea that the pandemic has brought to the fore the role of scientists in fighting diseases. And of course, it's very difficult to fight diseases, and I have an amazing story, because today on the set I have a scientist who is both a scientist, a Christian, a pastor. I don't know how she combines that, but we're going to hear this amazing story. And so, Dorcas, Professor Dorcas Yole, please welcome to the show.
Thank you very much.
It's good to have you.
Yes, thank you.
And I'm excited that you can come and share your story.
Thank you very much.
Okay, good. Now, as you all know, the Gigi Report is a platform where we delve into big, bold ideas, and we have honest conversation on a cross range of issues, social, economic, scientific. Today we're going to go into the science. Sometimes we deal with philosophical issues, theological issues. And so this is going to be exciting. And so let me introduce our guests, and then after that we'll get going. We are going to focus basically on the science of vaccines, an insider's view. You know, because we want to hear from the insiders. You know, there's been a lot of talk about vaccine, and so this is going to be exciting. My guest is Dorcas, Professor Dorcas Yole, and she is a professor of biology and director of the School of Biological and Life Sciences at the Technical University of Kenya, TUK. It's called TUK. Used to be called Kenya Polytechnic. I guess that's why I'm confusing it. And she's also an associate research scientist at the Institute of Primate Research, among other institutes that she's an associate. And Professor Dorcas is a senior pastor of the Faith Love Fellowship Church at Ongata Rongai. So Professor is also a pastor. So that's going to be interesting. So
yes,
welcome to the show.
Thank you very much for having me. I really appreciate for this opportunity.
Very, very good, very good. So let's get started.
Yes.
We'll start with, so tell us about your background.
Yes.
Including how you found your faith in Christ,
Yes.
and then what inspired you to pursue biological sciences.
I am Professor Dorcas. The company name is a little bit hard, Siokoi Yole. I'm married to Bishop Sami Yole Makau. Sami Yole Makau did his bachelor's degree in economics and business administration at the USA University of New Mexico. Mm-hmm. He was the pioneer, one of the pioneers of the Post Bank, but the Lord called him and he left banking, and he started what God had called him ministry.
Okay.
And then we've got two children, Ruth Yole Makau. Yole is, Ruth Mumbua Yole is a designer. Mm-hmm. She did a Bachelor of Arts in Design from the University of Nairobi. Mm-hmm. She's an entrepreneur. She's a fashion designer. She bakes very good cakes. She does makeup. She does photography. She's a gifted girl, many gifts. But she's chosen to be an entrepreneur than to be employed. We've got our son, we've got only 2 children, Michael Makau Yole. He is a student of aeronautical engineering at the Technical University of Kenya, but also he's an entrepreneur. He's got 2 companies, one Radi Aerospace, and the other one is on music, Alazetu. So this, we thank God, and this with much humility. Our children love the Lord. We brought them up, we had devotions with them, but when they got to 18, I told them, you have to find God for yourself, and they love the Lord. They are serving at Nairobi Chapel, Gong Road. They requested us, especially our son, requested us to go and join the band, because our church doesn't have a big band. He's the one who plays the saxophone. And then because when you've got 2 children, they become like twins, the sister followed, and she sings soprano, alto, tenor. So we thank God for them.
Okay, good. How did you find the Lord?
Now, I thank God for a rich background in Christianity. My 2 grandparents, from my mother's side, was one of the first Christians, actually one of the first Kamba Christians under the African Inland Mission, and he helped to translate the Bible. On the paternal side, my grandfather got saved, and he just started evangelizing. We do not know, because he was not as educated as my maternal grandmom. And then my mother loved God, and she was the first of the 2 women, actually girls, who went to Bible school under African Inland Mission.
Okay.
And my father loved the Lord, but my mother was a very strong influence. She shared the gospel with me when I was 5 years. I gave my life to the Lord. I got water baptized at age 13.
Wow.
But it took a long while before I got spirit-filled, because my mother was a big influence for me, was in the 1940s revival. And because many people got spirit-filled messed up, she never agreed. But our father, who was spirit-filled, was the first person to introduce me to the Holy Spirit. And later, my husband, before we got married, taught me about the baptism of the Holy Spirit, and I prayed and got spirit-filled on my own.
All right. Amazing, amazing. So that's a big journey.
Yes.
And very nice background.
Yes.
Amazing heritage, Christian heritage,
yes,
that really laid the ground for you.
Yes.
But then you pursued academics like everyone.
Yes.
I noticed that you actually studied at Alliance Girls. Was
Yes.
that for A-level or O-level?
That was for A-level. O-level, I was taken at Precious Blood, Kilungu.
Okay.
And it was a beautiful school. I think it really molded my character.
Okay.
And then I went for my A-levels. From 5 and 6, I did 4 Ps, mathematics, physics, and chemistry. I loved the sciences. Actually, when I was in Form 4, I did much better, distinction 1, 2 in the arts. But
okay,
I was drawn to the sciences.
Okay, you were drawn to the sciences somehow.
Yes. Somehow, I was just drawn to the sciences.
Did you do biology in A-level?
Yes, I did. I did maths, physics, chemistry, and biology.
Okay, so you did 4 units.
Yes.
The common practice then was to do 3 units, yes, and a supplementary.
Yes.
But you went for 4.
Yes.
Plus a supplementary.
Yes.
Oh, amazing. Yes. Amazing.
Yes.
Amazing.
And my mother wanted me to be a doctor because she was very hardworking.
Yes.
Whenever she was tired, I would be the one who massage her and all that.
Okay.
And also my advisor in Form 6, but I did not want to do medicine because I didn't want to be controlled. I think I'm a free bird in a sense. So although I had grades to do medicine, I really felt drawn towards the sciences. Okay. So I chose, not because of grades, but by choice, I chose to do the sciences.
Okay, to do the sciences. So yes, you pursued biology, and you did it at bachelor's.
Yes.
Then you did it at master's.
Yes.
And then you did your PhD.
Yes.
What was your
PhD? So for my bachelor's, I did a major in zoology. They would at 3rd year they would pick, like, the top students, and in my class 9 of us were picked. And actually, that's where the seed of research was born.
Okay.
I was picked among the 9. Instead of doing 2 subjects, we'll do 1 and then do a project. And I had a very good supervisor, the late Professor Mumo, Jasper Mumo. And during my project, he worked with me. But during the master's, I did parasitology. During the master's, he did something which has actually helped me to stand up to now. I took him my first chapter, introduction, a literature review. And then he told me, I do not want to see you again until when you've got a complete thesis. And a year later, this was in September, a year later in August, I gave him a thesis. Because during the project, he had helped me learn how to do research. I gave him a thesis. The other supervisor was Professor Kinoti. I know many people know Professor Kinoti.
Okay.
So I thank God for that. Then I went to work in the Institute of Primate Research.
Yes.
And God was very gracious. I found that there was some funding to do a PhD.
Yeah.
Initially, I was not the choice, although the PhD was in my area, in bilharzia, schistosomiasis.
Okay.
Several people were interviewed.
Okay.
And for some reason, because God had reserved this for me, they never made it, even some of my classmates. And then the people who had interviewed me that March, this was 1990, that March 89, they told the owner of the project, we are not going to supervise any other person. We supervised Dorcas. She was good, so she's the one to go to the UK. And that's how I ended up in the UK, University of York, and Professor Alan Wilson, a brilliant scientist.
Right.
And I just thank God for the people he put in my life. And he was very strict with me. Actually, I was being helped by someone who had just gotten their PhD. And you ask him, why are you being a slave driver to Dorcas? But God used that to prepare me to be able to come back to Kenya and work as a scientist on my own and also train students because...
absolutely,
yes.
absolutely.
Yes.
Yeah, amazing, amazing. And those of you who are following this conversation, like I said, we are going to behind the scenes. So Professor Dorcas, you began to specialize in parasitology,
yes,
parasitology,
yes,
and the other one is immunology,
yes,
and the other specialization, I find that name very difficult.
Yes.
The bilharzia thing.
Yes.
Yes. Okay. So, and that is where you've spent most of your time.
Yes.
And most of your study has had to do with vaccine programs.
Yes.
In terms of, because parasitology obviously is dealing with parasites.
Yes.
Now, you know, right now we are invaded by a parasite all over the world.
Yes.
Parasite, which is a virus. So you happen to have spent most of your life dealing with these parasites.
Yes.
So you have a very inside story about it. Okay, so
yes.
So what I want you to speak into while we are talking about your academic journey is that so after you finished your PhD, you did your publications.
Yes.
So a lot of you watching, some of you are postgraduate students, some of you are pursuing sciences, and you're interested in knowing how to navigate this world of science, research, and all that. And I'm going to ask Dorcas, because Professor Dorcas, when I checked you on Google Scholar is a place where you can check somebody out, anybody who is a scientist, then you can see what they have published, what they have done. I noticed that you have published a lot of work, and you have accumulated over 1,300 citations. First of all, that citation is a big thing. So tell us how all that worked. What does it take to really produce that kind of work and be so cited?
Thank you very much. I have got, for those who go for papers, I've got 54 published papers.
Okay.
And I've got 10 manuals, call them books, which I've contributed on, and 8 of them are with World Health Organization.
Okay.
Doing preclinical work. Some of them are on preclinical work. One of them is on basic science, and then the other one is on actually just before you start testing drugs.
Okay.
And what helped me again is to have a supervisor who was focused.
Okay.
My supervisor, Professor Alan Wilson, demanded that we publish in the best journals.
Okay.
And I know at that time, if one is doing parasitology,
Yes.
Parasitology journal was the journal to go.
Okay. Okay.
So I published my first paper, the baboon paper you've been talking about in parasitology, journal on parasitology.
Yes.
And so that is one, just having a supervisor.
Yes.
And you know, Gigi, that has really helped me help my students.
Yes.
All these publications are not just me.
Yes.
Every student I supervise, normally my greatest work is to find a project with them and go to the lab with them.
Okay.
And especially during the master's period.
Okay.
That, you know, because really a master's degree is really techniques.
Yes.
So during the master's project, I work with my students on my projects. Usually in the PhD, I give them a little bit of leeway, but most of the projects are my projects. And if you look at my CV, you will find that I've published a lot of work with my students.
Okay, yes,
And
yes.
that is another thing. And as a professional, usually for me, I don't tell them, go and work and put my name.
Yes.
It's many times my idea, and I work with them, I review their work. Sometimes they say I'm a little bit tough, especially when it comes to thesis.
Yes.
And then usually it's a condition. Like for me, for master students, for me, the condition was, if you are not going to publish and I write the paper for you, I'll be the first author.
Yes.
But if you write the paper, you will be the first author, even at master's level.
Okay.
So that has helped a lot. And so, you know, the supervision is critical.
Okay.
So, and for the students,
okay,
please do not just be so keen to finish your thesis and go home.
Yes.
Because normally when you don't publish immediately, you tend to forget.
Yes.
And then things come up with life, and then that's it. And I like it now. Nowadays, you know, the universities, our universities are put restriction that, like for a Master of Science, you have to have one paper, at least accepted, and for PhD, like in the Technical University of Kenya, 2 publications. And that helps, because once one picks that discipline of writing papers, they're good to go.
Okay.
Then now, during our time, it wasn't, the journals we published on were very credible. But now the predatory journals, we just want money. They will not thoroughly critique your work. Actually, within a few days, your paper is out. So that is something one, especially the students have to be aware, especially if it's their first time to publish. And that's why you need to work with a senior person to help you, or even go to a place like the Scopus to help you know which is a predatory journal, which is not a predatory journal, so that if you publish, your work will not go to waste.
Absolutely,
Yes,
absolutely.
yeah.
So very, very good. So those of you who are watching us, your scientists, your master students or bachelors in the sciences or whatever other domain, there's a lot of help, and you can become a well-known scientist if you actually published. And Professor Dorcas basically is insisting that you need to pay attention to that, and when you do, the rewards are always there for us. Now we are going to look at the behind the scenes on the issues of parasitology, immunology, and all that. I want us to begin, because right now, one of the biggest conversation right now, we are talking about vaccines.
Yes.
So, and you've done a lot of work in the research and the vaccine, behind the scenes on vaccine work. So first of all, give us a view of how vaccines work. The general mechanisms
of
vaccines.
Yes, thank you very much. I want to state that actually immunology is the basis for vaccines. And when we did immunology in the University of Nairobi in undergraduate, those were like the first students. And as I said, Professor Mumo was an immunologist. And the way he taught us, it was a very difficult subject at that time. It made me interested in immunology. In addition, I also do, and so that you may understand, I also do drug development, and I'll just say this so that people will be informed. We've been working with my master's student and PhD student on development of drugs, especially for bilharzia, schistosomiasis, using our Kenyan plants. And we are at the level whereby now, like the 2 PhD students which we have who are working on this, one on malaria and one on bilharzia, we are in the stage whereby we want to get the compounds. Once you get the compounds, it's very easy to partner with a pharmaceutical company.
Yes.
And then instead of going again to the plant, they can actually formulate that. So that is one of the work I do. And also I do work on vectors. Snails are the ones which transmit bilharzia. I am also working with my students on drugs which can actually stop that life cycle. That's done with drugs and vaccines. My third year project, when I was doing my bachelor's, was on vaccines.
Yes.
On schistosomiasis.
Yes.
And when I went to do my master's, it was also on vaccines and again on schistosomiasis.
Yes.
And so when I went to do my PhD,
yes,
it was the same thing.
Okay.
My main area of specialization is parasites. Parasites are those things which live on your body and like malaria, and they don't benefit you. They actually harm you.
Yes.
And then so that's parasites, malaria, schistosomiasis, leishmania, all that.
Yeah.
And then vaccines. Why vaccines?
Yes.
Drugs will treat, and I'll use bilharzia as an example.
Yeah.
If someone has got bilharzia,
yeah,
and we give them the best drug is Praziquantel,
yeah,
they take it, they'll be cured.
Yes.
They go tomorrow into a river which has got snails which are producing the bilharzia parasites to get infected.
Yes.
And again, we come and treat them.
Yes.
And with time, you get what you call drug resistance.
Okay.
The parasite knows how to escape your immunity.
Okay.
The beauty of vaccines, and then I will go to how they work, is that once you develop a vaccine, think of polio.
Yes. Polio is the best example.
Think of BCG.
Okay.
Many times it will be a lifetime because your body will have learned how to protect itself. So let me discuss on how vaccines are developed.
Okay.
Vaccines are developed from the disease organisms. That is the starting point.
That is very interesting because
you have to have you have to have molecules, and many times immunization comes from proteins. So many times, sometimes you'll have the sugars, but many times it's the proteins.
Yes.
So for one to develop a vaccine, they have to get a protein from the disease-causing organism.
Yes.
And develop a vaccine.
Yes.
The vaccine will be able, usually diseases produce an immune response. The way God has created us is that when we get infected, we actually produce an immune response. I'll go to details later. An immune response, normally, by the way, we never have to go to hospitals for many things. If we knew the many things we get, like now in this room, there are so many things I'm breathing right now, and my body will deal with them.
Yes.
Usually we get overwhelmed when our immune system is not able to deal with diseases.
Okay.
And that's why we'll come down with malaria and all that.
Yeah.
So one gets a protein from the disease-causing organism.
Yeah.
That protein will actually produce some little disease, and that's why we need to understand when a child gets vaccinated, they cry and they got a fever.
Yes.
Usually that is because of an immunological reaction. The body immune system is now fighting this little disease called the vaccine.
Yes.
And then after it fights this, and then it completely conquers this, because normally they are made in such a way that they will not overwhelm you.
Yeah.
Then they will develop something called memory.
Okay.
And then there are memory cells. I'll talk about them later. Memory cells, which are actually now staying in your body, very small population.
Yeah.
The next time the actual disease comes, The body pulls out the memory cells, the immune cells, and then they attack. And then the attack is stronger than the one which had been produced by the vaccine.
Okay.
The third time, the attack will be stronger.
Yes.
The fourth time, stronger and stronger. And that's the beauty of vaccines.
Okay.
That's why one is able to get protected.
Yeah.
How do we develop vaccines?
Yeah. So we're going to go into the technical bit.
Yes.
But just expound on
Yes.
a small organism,
Yes.
which is like a protein,
Yes.
which is taken from the disease-causing organism,
Yes.
whether it's a virus or a bacteria
Yes.
or whatever kind of
Yes.
parasite.
Yes.
So the work of the scientist is to calibrate that protein such
Yes.
that it is small enough so that it doesn't overwhelm your body, but then it triggers your body to develop a way of, it triggers your immune system.
Yes.
And leaves behind memory.
Memory, yes.
So is that the same mechanism that like the COVID-19 vaccine is based on?
Yes. Now, let me just...
Although I know there are many varieties,
okay.
and we won't be able to go into
all
all
the
of them.
details, yes.
But we can, maybe we can just say, yes, that's the mechanism, although it's more complex.
Basically, it's actually, just briefly,
Yeah.
you've got different types of vaccines. There are the natural ones.
Yes.
Like for smallpox.
Yeah.
That's, actually a bacteria from cows put in human beings, natural, and it protects.
Yes.
There are those we call attenuated, like
Yes.
for many viruses and BCG.
Yeah.
It's the same pathogen, a bacteria or virus,
Yeah.
but it's worked on in the lab, sometimes by just culturing it.
Yes.
And it weakens its genetic material. So that if it's put in you,
Yeah.
it will produce the memory we want, but it will not harm you.
Okay.
Sometimes you just get an entire parasite,
Yeah.
pathogen, and kill it.
Yes.
And inject,
Yes.
and it produces protection.
Yes.
Sometimes we actually, like bacteria, produce toxins,
Yes.
poisons. Bacteria don't kill us because when we have got runny tummy, it's not because of the bacteria, it's because of the poison.
Okay.
Sometimes we just take the poison
Yeah.
and inactivate it and use it as a vaccine.
Okay.
Okay. Sometimes I told you that many of the vaccines are proteins. Some of them are not proteins. Some of them are sugars.
Yes.
So the molecule we want can be a sugar. So we get it and combine it with a protein,
Yes.
and it will produce the immune response.
Yeah.
And then what you're talking, like sometimes, which is very rare,
Yeah.
we get, like in hepatitis B, some little proteins which cause, which can be used as a vaccine. These ones are very easy because we just either clone them, or we just take them to the pharmacies and just produce many of these little things and use them. So those are the way. Now, with the COVID vaccines,
Yes.
this is a rather newer technology.
Okay.
We are actually using proteins.
Yes.
I'll talk about that. Proteins which actually instruct our, I know many of us know DNA.
Yeah.
DNA
Uh-huh.
to produce the pathogen protein.
Okay.
And then that pathogen protein will be reacted. Do you want me now to go through the process? Is that easier right now? Do you want me to go through
I know it's interesting.
Yes.
And there are people who are paying attention to what we're
Yes.
talking about.
Yes.
Because the more you understand,
Yes.
then the more the more you're able to kind of like discount some of the conspiracy theories that
Yes.
fly around on
Yes.
WhatsApp, on social
Yes.
media. There's
Yes.
a lot of stuff that fly around.
Yes.
And so it's important. I know we may not be able to go very deep into the technical stuff.
Yes.
But I like what you're describing. So, but we're going to go into a short break.
Yes. Thank you.
When
very
we
much.
come back,
Yes.
we're going to go back to that mechanism because
Yes.
I really want people to understand that the vaccine technology
Yes.
is not new. It is not. Nobody should be scared about it, and there are people who have the behind the scene, behind the story. So we're going to a short break. Please don't go away. I am sure you want to hear what happens next. God bless you. Please stay tuned. See you shortly.
Thy Kingdom Come, 14 Days of Hope to the Church and Nation, 19th April to 2nd May 2021. Online every weekday between 4 to 6 p.m. on Elevate TV and Life Church International's Facebook and YouTube pages. Hosted by Apostle David Juma and Pastor Asunta Juma. Bringing together a battery of men and women of God with a word and prayer for you. Stay tuned.
Welcome back to the Gigi Report. Today it's exciting. Today we're speaking a lot of science, and I believe that you're tuned in and you're learning. Now, before we went to the break, Professor Dorcas, you're talking about the mechanism of how vaccines work.
Yes.
Because I think a lot of people who now we've all been thrown into this arena.
Yes,
so
yes.
all of us have become kind of some semi-scientists
Yes.
because we have to interact with this
Yes.
information. Yeah.
Yes.
So it's good to clarify
Yes.
that mechanism of the vaccine.
Yes.
That's what you were explaining before we into a break.
Yes.
Could you continue that?
Yes. Just to start, viruses are little crazy animals. They are able to change themselves
Okay.
very quickly, and that's why it's such a challenge
Yeah.
to produce vaccines against viruses.
Mm-hmm.
And I know you've heard about the strains. That's the reason. So a strain, a virus will be, a vaccine will be working, then a strain comes and it's not working as good.
Yeah.
So let me explain the mechanisms. Basically, now the vaccines which the federal FDA
Yeah.
has given them emergency authorization to manufacture. Let
Yeah.
me retract. Normally, to develop a vaccine
Yeah.
and actually administer it to humans take a long time.
Yes.
But usually, because it has to be tested in small groups of people,
Yeah,
then
first
larger
trial,
group,
second trial.
phase 3 and phase 3,
Yeah.
and like phase 2 and phase 3, there is a group which is being given what we call placebo. It could be Chumbi 2 saline,
Yeah.
and then the other one given the drug.
Yeah.
And then not only that, there are effects which can come many years later or in offsprings. So normally vaccines take a very long time to develop. But during a pandemic like now,
Yeah.
FDA will allow, and even Europe and Britain will allow vaccines to be used even though they've not gone through the entire process.
Approved on an emergency basis.
Yes.
Exactly.
So the two vaccines the two types of vaccines which we're having is
Yeah.
one, Pfizer
Yeah.
is based on what we call mRNA.
Yes.
Messenger RNA.
Yes.
This is a protein
Yeah.
which instructs our DNA. The good thing is we know about DNA.
Yes.
So our DNA to produce proteins which are needed in the body.
Okay.
So what they do, because RNA, the protein is very fragile,
Yes.
they coat it with oil
Yes.
and then they inject it.
Yes.
When it gets close to our cells,
Yes.
it actually attaches,
Yes.
releases the messenger RNA.
Yes.
The messenger RNA travels straight into the nucleus,
Yes.
finds our DNA and tells the DNA,
Yeah.
make spike proteins.
Yes.
I think all of us know about the spike proteins of the coronavirus. Those ugly things,
Yes,
those
yes.
ugly things.
Yes.
And that is actually what has been used for. That's the protein which has been used actually for
Yeah.
making vaccines.
Yeah.
So the messenger RNA gives the information to DNA.
Yeah.
DNA instructs the system outside the nucleus
Yeah.
to start manufacturing these proteins.
Yes.
Those spike proteins are produced.
Yeah.
Some stick on the outside of the cell, and it actually looks like a coronavirus.
Yes, yes.
And then some are chopped to small protein particles, fragments called peptides.
Yeah.
And those are presented by a very special molecule,
Yeah.
which takes it out, and when they are presented this way,
Yeah.
they are able to be recognized by an immune cell, which is called T helper cell.
Okay.
I will stop there so that I may go back to the other.
The other, like the
Oxford,
AstraZeneca.
AstraZeneca.
Yes.
The AstraZeneca, Johnson's, and the Russian vaccine
Yeah.
use a different method.
Okay.
They actually use DNA.
Okay.
And then the DNA is put in a vehicle,
Yes.
another virus called adenovirus,
Yes.
which normally causes flu.
Yes.
But someone recovers.
Yes.
Like the one which have been used by AstraZeneca is a chimpanzee virus. So again, it's injected.
Yes.
It gets into the body.
Yes.
It attaches to the cell.
Yeah.
It penetrates the cell.
Yes.
And then the vector travels all the way to the nucleus, doesn't get in the nucleus, it injects the DNA material
Yes.
in the nucleus.
Yes.
And then now the DNA material in the nucleus
Yes.
now starts instructing development of the spike proteins again.
Yes.
So now, and then the proteins are again stuck outside,
Yes.
and also their fragments are also presented by a special molecule, we normally call it MHC,
Yes.
on the surface. So
Yeah.
how does the immunology work? Usually cells don't live forever. They actually die.
Yes.
When they die, they disintegrate.
Yes.
And these particles, the spikes and the peptides
Yeah.
get released into the system.
Yes.
There's a very special immune cell called antigen-presenting cells. There are a group of them, macrophages, neutrophils, all that.
Yeah.
So they pick up dendritic cells, not neutrophils, dendritic cells, macrophages. They pick up this protein,
The fragments.
the fragment,
Yeah.
and even the protein, the
Yes.
spike protein. They chop it into peptides, and then they put it outside with that special molecule I told you called MHC, and then they present it to a very key cell in the immune system, T helper cell.
Yes.
T helper cell reads the message on the peptide, and then it produces things I know you've heard called cytokines.
Okay.
These are molecules which control the immune system.
Okay.
So let's leave the T cell there.
Yes.
So the T cell will produce variants, many different types of molecule. Now, let's go to the B cell, which many of us know about. The B cell also can present antigen. You take the spike protein of the fragments, chop them up, present again to the T cell. The T cell will produce against cytokines, which it sends back to the B cell and tells the B cell they are called like interleukin 4, interleukin 5. That's scientific, but it's those molecules which are sent to the B cell to produce antibody.
Yes.
When they are sent back, the B cell multiplies a lot, produces antibodies.
Yes.
And we know antibodies.
Yes.
So how do antibodies protect us?
Yes.
Antibodies are in our circulation.
Yes.
And viruses will be in our circulation. When a virus comes,
Yeah.
our COVID virus,
Yeah.
the antibodies work in two ways.
Yeah.
They will either attach to the spikes. Remember, the antibodies against the spikes.
Yes.
And when they attach the spikes of the coronavirus, it cannot now attach to the cell and inject.
It's poison.
Is DNA. Actually, normally it's just
DNA.
genomic material
Yeah.
into the cell
Yeah.
for the infection to develop.
Yeah.
The other way they work is that they will attach to the virus and then also attach to other cells we call effector cells like macrophages.
Yes.
And these cells will come and eat the entire cell with the virus.
Yes.
You understand? So
Yes.
it's destroyed.
Yes.
So those are antibodies. We've got other cells called T killer cell.
Okay.
Their function is to attach to a virally infected cell,
Okay.
a cell with COVID.
Yes.
And they actually just destroy it, kill it.
Absolutely.
And they are activated by the cytokines produced by our T cell.
Okay.
And then, after the viral infection is done, then we develop memory cells. So the next time we get a COVID a virus, we fight it better. The third time, even much better. That's the way.
Absolutely. Okay. Thank you so much, Professor Yole. Yeah. I know it's very technical. It's not too technical, because I know there are people watching that have been reading a lot of stuff on Google. So, yes. So now probably they are clearer what's been going on.
Yes.
And so what you're saying in summary, the good news is that the vaccine mechanism is such that to trigger the body immunity system to activate, and you've actually gone into the technical bit of it, how it actually does happen. And once that happens, you're saying the first, so it fights off the first, attack.
Yes.
Another one comes, it even fights it harder.
Yes.
Another one comes, it even fights it harder. Is that the reason why you need first dose and second dose?
Yes. Now, you are very right. There are some vaccines like Johnson & Johnson's.
It's one single dose.
It's by 10 days, it's fine. You're good to go.
You're good.
Yeah. AstraZeneca, you have to have 2 doses to actually boost. Why? Because with the DNA,
yes,
because it's being put in a vector,
yeah,
the body is so used to these vectors,
yes,
and adenoviruses,
yes,
it's going to actually kill.
Yes.
So actually the body kills some of the cells carrying viruses carrying our vaccine, so they never ever get to our cells.
Okay.
So that's why you need to boost. So that's the difference. The Russian vaccine, what they've done with the Russian vaccine, and I like the Oxford vaccine, is that they've used different factors. So that, you see, the first factor will be noticed. The body will know about the adenovirus and also the COVID.
Yes.
But now the Russians are very clever. They don't use this, for the second dose, they use another adenovirus. Yeah. So the body is confused, and so they are able to fight. So that's how it fights. I know, as I said, I understand people's anxiety.
Yes, yes. Explain about the anxiety, the issue of what are the risks involved.
Yes.
How does the body eventually over time?
Yes, yes.
I know we don't have data. Well,
yes.
I'm saying I know as though but anyway,
yes.
This whole thing, the virus, the vaccine system started on the other day.
Yes.
Scientists are busy gathering data to see what the unknown effects are.
Yes.
So you could speak into that.
Yeah, okay. Most of these vaccines have gone through the 3rd phase trial with like 40,000 people, but that, as you said, that is not enough.
Yeah.
And because of that, people are anxious because of side effects.
Yes.
You've heard about
clotting.
Clot.
Yeah.
AstraZeneca.
Yeah.
And also now with yesterday when I was going through also Johnson & Johnson, FDA has said to pause them a bit so that we may look at the clot. Of course, like for Johnson & Johnson, it's 1 person in a million. So usually the side effects, and that's why many vaccines are not out there.
Yes.
Because apart from a vaccine being efficacious, working, it has to be safe.
Yes. Yes.
And these vaccines are being rolled out so quickly.
Yes.
And so I can understand people's anxiety that we don't know enough.
Yes.
Of course, the other thing is the technique of putting something in your DNA, in your nucleus, where your DNA lives, is making people anxious. What if this DNA combines with my DNA per chance?
Yeah.
And usually DNAs, they are usually 2 strands. They exchange materials.
Yes.
And if it combines, it will not just take where it is.
Yes.
It can actually change and combine with my DNA. What will it produce?
So those are the concerns.
Those are the concerns, and they understand it. And that's why I would say, please, we are here because of those jabs, those vaccines we got when we were babies.
Actually, that's the message. Those of you who are watching,
yes,
you're probably alive because of the jab you got when you are a baby.
Yes.
So please, for goodness sake, you survived to listen to us because you got some vaccination. Yes. So don't be quick to discount vaccine technology, because otherwise you wouldn't even be talking.
Yes. So for me, the vaccine technology is fine. I've been working most of my life on vaccines for schistosomiasis.
Yes.
My first work was very promising. I got 94%. But why it was not allowed to go through is because I was getting the parasite which comes into human, and at what you call attenuating, reducing its virulence.
Yeah.
It worked in baboons, but I was giving like 800. So I was told, what of if you've not attenuated it? But if that was not the case, we will not be struggling with bilharzia.
Okay.
So vaccine technology is the best technology compared to drugs, because once your body is educated, the immune system will keep on fighting, unless when it's immunocompromised.
Okay.
By some diseases or by chemotherapy.
Okay.
So what I would say to my viewers is, just let's listen to the government. If you are at that age where, like us, where, you are not thinking of babies later on, please go for it. Or if you've got another condition which can actually make you fast. Many people are dying, those people with other condition, tension and all that, immune depression and all that, they are the ones who are suffering. So if someone has got a condition, and if they are 58 and above, please take, because it's better to have you alive.
It is better to be alive.
Yes.
And so what you're saying is there is risk in the vaccine, scenario.
Yes.
However, you have to ask yourself.
Yes.
I read somewhere, and maybe you can verify that in the British AstraZeneca, some of the data they have gathered so far, I think a week ago, after vaccinating 27,000, they had a few, I think 3 or 4 or 5 clots scenarios. So you're talking about 27 million versus that. So in terms of risk, the probability of risk is not zero, but it is very, very small. So of course, it's not zero.
Yes.
So, and that's the only problem. The problem is that it's not zero.
Yes.
Risk is not zero. So, scientists know that language.
Yes, it's so true.
So the fact that it's not zero means that there is something.
Yes.
But if you look at the risk versus the benefit, that risk is so small.
Yes.
I mean, if you apply probability theory, apply whatever game theory, clearly we cannot throw the vaccine. It's like throwing the baby with the bath water.
Yes.
So there is something to be gained.
Yes.
So one would rather even go out and take that risk, if they so feel, than risking something else much bigger and something that you're not very sure about.
Yes. And also the other thing I want to point out, remember, it's also Pfizer, which is 95% protective.
Yeah.
And so there's a percentage. Some of us will be vaccinated, will still get infected.
Yeah.
But the good thing is we will not suffer the fatal
severe
disease.
Okay.
So someone might be sick, but definitely some people would get the infection, but you will not have to go all the way until death. So,
okay. So when you say 95%, you're saying that 5% are people who will still get the infection, and they will manifest some kind of disease condition, but it will not be extremely severe, and it may not. So in other words, we're saying it doesn't quite completely eliminate possibility of your body manifesting any symptoms. But even if it does, you will not get to the severe condition. So at the end of the day, no one vaccinated should actually die.
Unless
something
no
else.
more death, because normally COVID or no COVID, we still die.
We still die. So we are in this. We are in this. It's like a battle, with these things. Great. I love this. Those of you that are following us, so you're free to send a text, comment on the social media, links on the screen, below the screen. You can see them, Facebook, YouTube. This thing is actually on YouTube and Facebook Live, so you can comment and ask a question or make a call or share with other people so that they can learn this story. So I think you've given us a lot of very, very wonderful information. There's something you mentioned that maybe I would like you to comment a little bit about the risk of somebody who is at the, women, especially childbearing age. Is there something we should be concerned there?
No, I think none of these vaccines are being given to pregnant mothers or people who are planning to get pregnant.
Okay.
And again, we don't know enough yet.
Okay.
We don't know enough yet.
And most people who are in that age are
Yes.
obviously less than 58.
Yes.
So
Yes.
perhaps their current immunity system can take them through. They can survive it.
Yes, yes.
But if somebody has a precondition, they would rather weigh the two options
Yes.
and say, okay,
Yes.
fine. We don't know the risk or on the side of reproductive
Data, yes,
side of,
Yes,
of life, but again, you don't want to risk extreme disease condition.
Yes, yes.
So you can still take the vaccine
Yes.
based on that. So it's
Yes.
up to each individual person to weigh that matter and perhaps talk to their doctor.
Yes, yes. Absolutely, absolutely. And also the other thing we need to know, just because you've gotten the jab, you still keep the protocol. You can see we are keeping distance from pastor.
Yes.
We are giving, you still keep to the protocol because
Yes.
you can still get infected. There are some chances
Yeah.
of getting infected. You
Yeah.
know, AstraZeneca is 75%. There are chances of getting infected. So let's stick to the protocols. Let's not, stop sticking to the protocols. And especially also, those who do not, especially who don't want to get the vaccine, they really, really need to adhere. Really,
to the protocol.
And anyway, in Kenya, not everyone will be able to be vaccinated because of the challenges.
Okay.
So we are really taking care of the frontline workers and all that.
Yeah, people who are more predisposed
Yes.
to catching the infection
Yes.
because of the nature of their work.
Yes.
Absolutely. I love this. I love this. So, Professor Dorcas, I am very excited that, you've been able to expound this. It's like a look behind the scene because this COVID situation has brought in a lot of challenges. People are so, there's fear, there are concerns, plus a lot of information flowing that can be very confusing. Okay, great. We'll leave that at that.
Yes.
But now let's go back to the science.
Yes.
There are a lot of young women out there and young people coming up as scientists.
Yes.
I'm sure you have some inspiration for them.
Yes.
Plus, of course, also telling us how you manage your pastoral work and your scientific work. That I think this is interesting. You're a scientist and a pastor and a lecturer, a teacher.
Yes.
So you combine those things.
Yes.
So first of all, speak to the balancing bait.
Yes.
And then talk to young people who are
yes.
aspiring scientists and encourage them.
Yes. I thank God because He gave me a mother who was very hardworking.
Okay.
And yet a time for us. I'm not giving advice to, this might not apply to everyone. The good thing is I have decided to prioritize my life. Who comes first? God. Amazingly, then me. Because Jesus said, love others as you love yourself. If I don't take care of myself, I can't take care of others. My husband.
Yes.
My children.
Yes.
Work and ministry.
Okay. In that order.
In that order.
I love that. I love that.
Yes. So I've had to make some sacrifices. Socially, I really must say that I'm not in many chamas.
Yes.
I've had to sacrifice my social life so that I may be able to really give my work to research and give my work to family.
Okay.
Make sure my husband doesn't feel threatened by my research work and give time to my children. Our children are very gifted, and many people are in education know that gifted children, are special need children.
Yeah.
And one thing when our son was in class 7, I said I'll not have house helps.
Yeah.
I wanted to spend time with them. The initial time would cook with them, would do things with them. And And that gave me quality time because we could talk whatever we wanted in the kitchen. They actually told me, Mom, we are so grateful. We can talk, we can shout, we can be ourselves, we can be angry without caring whoever listens. I know it doesn't work for everyone, but that one worked for me. Why? As a scientist, I didn't have to go to work. I don't have to clock in 8 to 9, provided I do my hours. Many times, the other way I've been able to manage is I work a little bit late, and my family knows that. I like after 5 because there's no one there, no one in the office. My office is only me, and I'm able to do a lot. When the children were younger, I would put all of them in bed, plus my husband, make sure everybody is happy. Then sneak out of bed and read our thesis. By morning I would have finished. So it really takes a lot of balancing and prayer.
Absolutely.
And the same with the ministry. I'm there to know, because the only thing we go to heaven with is human beings.
Yes.
And I need to help human beings know the Lord, love the Lord, because eternity is real, hell is real, and heaven is real. So if I spend all my time doing all this fascinating work, and then I forget about human beings, then I stand before the Lord, what will I tell him?
Absolutely. Absolutely. And your research and publications, yes, that's good work. It saves lives and it helps spread the kind of information that is needed, but it's important to focus on people.
Yes.
That's wonderful. That's amazing. That's amazing. Now, we are out of time. We are coming to the end of this program. And thank you so much, Professor Dorcas, for your wonderful, wonderful insights and contribution and helping us to understand these things. And so I want you to look at that camera and speak to some young girls in 30 seconds, and young women and young men, and give them a word of inspiration.
Young people, I will be 60 this year. It's possible to make it in the science world. You face challenges because of the funding. I'm grateful that now the government has committed 2% of our GDP to research. Of course, this year and last year was a challenge, but see what the Western world has done. We've been crying about malaria, about schisto, about leishmania for years. But when they were hit by COVID, they reacted. African problems are our problems. There might not be much money. I'm not a wealthy woman, but we need scientists like you to take over where I've stopped and give us the vaccines, give us the drugs, help our community. God bless you.
Absolutely. Absolutely. Thank you so much, Professor. I am so excited of your wonderful, wonderful, wonderful contribution and words of wisdom. Now, we've come to the end of today's show. I am so excited that we've learned so much. I've learned so much. And that's all we had for you. We promise you more in the coming days. And please be, be able to tune in our next program when we come back. So today it's been your host, Godfrey Gishoke, and I'm so excited that you've stayed tuned in. God bless you. See you next time. Bye.